Hello, you're watching News 9 Live. I'm Prajwal D'Souza. Now, for years, doctors and the scientific community have been working towards developing new and less harmful ways of treating skin cancer. While surgery and chemotherapy are generally used for treating cancer, chemotherapy also has several side effects and several limitations. Now, researchers at Bengaluru's Indian Institute of Science have developed a non-invasive bandage made with magnetic nanofibers to treat skin cancer by administering heat to the tumor cell. Now, how exactly does the technology work? Now, to explain this, I am joined by Kaushik Suneet, who is the lead researcher and author of the study. Now, first of all, congratulations, Kaushik, and thank you for joining me on this live interaction.
Oh, thank you, Prajit.
So now, what is a non-invasive bandage and how does it work, Kaushik?
So usually non-invasive means we don't puncture skin or we don't make a cavity in a skin. So we fabricated this fiber which is can be treated for skin cancer non-invasively by the method of alternating magnetic field. So this bandage is made with a polycaprolactone, a biocompatible polymer, and fused with iron oxide nanoparticles. So these iron oxide nanoparticles get excited when alternating magnetic field is applied, and it produces heat. So that heat, we use it as hypothermia therapy. So this would be the whole gist of how this study has happened, and that is how it works as well. So if you consider, so there are several therapies for skin cancer, as you said, like surgery, chemo, radiation.
Yes.
So in surgery, what happens? There are possibilities where there is a recurrence of cancer and wound infection, and that kind of stuff happens with surgery. And chemo, as you said, there are side effects. So with this bandage, you can use it in places where even you can't do with surgery. Suppose it is on your ear, earlobe, nose, eyelids. So you can basically paste this bandage on top and subject it to alternating magnetic field. So that mat produces 45 degrees Celsius. Like it can actually reach to 55 degrees. But for our study, we keep it around 45 degrees Celsius. And we subject that heat. And what happens is, like, if you subject that heat for 3, 4, 5 cycles, the tumor reduces. So that is how this works.
Now, what is the nanofiber tech that is used in the treatment, Kaushik? What exactly is this nanofiber technology?
So in this technology, so as I said in the previous question, we use this polymer called polycaprolactone and iron oxide nanoparticles. So we mix this to sonication and other solvents, and we make this a homogeneous mixture. So this homogeneous mixture can be made into a mat of diameter like extremely less, like 100 to 1000 nanometers. This mat can be fabricated using a process called electrospinning. So electrospinning is a fiber production method where you use electric force to take the charged particles and make into fibers, where you can put an aluminum foil down and you can take those fibers. That is how electrospinning works. So, so these are the major components, like iron oxide and the PCl. That is the whole composition of the mat. And because of the alternating magnetic field, so I wanted to let you know how this works on treatment of skin cancer. So when the heat...
Yes, please go ahead.
Hello?
Yes, go ahead, Kaushik.
Yes. So the fibrous mat dissipates heat when the AMF is applied. So usually skin tumor, the tumor region has a compact vasculature. The blood vessels, all those stuff will be random and it will be extremely compact. When compared to healthy cells, the blood vasculature will be like really healthy and it will be normal. So when you subject heat to these tumor regions, because of heat, how do I say, like the heat doesn't dissipate with other cells and it ruptures. So when it ruptures, there is no nutrients going to these tumor cells. So invariably the tumor regresses. So that is how this skin tumor is treated. And when compared with healthy cells, the vasculature is perfect. So the heat dissipates naturally and it doesn't have any effect on it. So that is how this works. And
now, Kaushik, in the study you have talked about magnetic hypothermia. Now, what exactly is magnetic hypothermia, Kaushik?
So magnetic hypothermia is actually a principle of delivering heat energy locally using magnetic nanoparticles with the application of alternating magnetic field.
Okay.
So, as I said, these ionoxide nanoparticles gets excited when the magnetic field is applied. Suppose, consider you excited nanoparticles with magnetic field and you oscillate the magnetic field from left to right, like oscillate that.
Okay.
So what happens is the ionoxide nanoparticles also oscillates. So when it oscillates, it produces heat energy.
Okay.
So that is how, so that heat energy can go up to 55 degrees, but magnetic hypothermia, we take it to 46 degrees Celsius, 45 degrees, we use it on a study.
Okay. So to put it simply, hypothermia means applying heat to the tumor cells, is it?
Yes, delivering heat energy locally to other tissues from 40 degrees to 45 degrees Celsius through magnetic field, alternating magnetic field. So that is what we call it as magnetic hypothermia.
Okay. Now, Kaushik, has the study been peer reviewed yet?
Yes, it has been published in Cancer Reports, so which is an international peer review journal.
So, yes. So right now, this is still a novel treatment, right? This is still it's in first stage. There are many more experiments to be done, right?
Yes, still this is in the nascent stage. We still have like lot of research needs to be done to even take it to human levels, like clinical trials. Like first, as of now, we have done successfully with mice.
Yes.
But later on, we have to go with monkey and rabbits. Then that works in human trial starts.
Okay. Now, Kaushik, there have been talks about nanotechnology, as the tech of the future. Where do you stand on it, Kaushik?
I think nanotech is nanotech actually has great potential in India as of now. So even in IISc, they have developed nanobots, nano swimmers, where you can actually these nano swimmers can get into a cancer cell environment and detect those environment. Like what is happening. I think there is a really good future with nanorobots and nanomedicines, and I would love to see where it goes to.
Yes. Thank you, Kaushik, for joining us, and thank you for this great and congratulations again for this great feat. Now, what should be noted here is that the novel treatment has shown to be effective against skin cancer in lab experiments. However, it is still at a nascent stage of development as a clinical therapy. Now, the efforts of the research team at IISc have been truly commendable. If you like this video, please click on the like button and don't forget to subscribe to News 9 on all the social media platforms. Thank you for watching and have a great day.